Welcome everybody to another HFES webinar. For this webinar, we're having a presentation from Dr. Joe Lyons on Trust and Automation, Lessons Learned from Auto GCAS. But first, a little bit about the webinar series. The webinar series began in 2011, and it's organized by the Education and Training Committee of HFES. And we draw topics from many different sources. Certainly, we draw them from member surveys. We have had multiple surveys in the past asking about education and training needs. We also use topics that are of interest by members from the annual surveys at the meetings. And at any point in time, if you have a topic you're interested in, or if you have a recommendation for a speaker for the webinar series, feel free to contact me. I'm Dr. Chris Bro. I'm the webinar series coordinator, and my contact information is listed here on the slide. You can always see upcoming and past webinars at the HFES website, so feel free to visit it. This HFES webinar is being recorded. It's a member benefit. So for those of you who are out there who are members, you can go to the HFES website and view past webinars. There are no kind of CEUs for the webinar. You listen to webinars over speakers or via the telephone. If you are listening over speakers, make sure your speaker volume is turned on in your operating system and the speakers are turned on. All attendees are muted, so only the presenters can be heard. However, if at any point you need to contact us or communicate, just use the chat menu in Zoom. If you are experiencing any kind of technical issues during the webinar, visit www.zoom.us and click on the support link. HFES subscribes to the service and cannot provide technical issues related to the webinar service. So, without any further ado, I'd like to introduce our speaker. Joseph B. Lyons is the technical advisor for the Human Trust and Interaction Branch within the 711th Human Performance Wing at Wright-Patterson Air Force Base. He received his PhD in IO psychology from Wright State University in 2005. Some of his research interests include human-machine trust, interpersonal trust, leadership, and social influence. He has worked for the Air Force Research Laboratory as a civilian since 2005. Between 2011 and 2013, he served as a program officer at the Air Force Office of Scientific Research, where he created a basic research portfolio to study both interpersonal and human-machine trust. Joe is published in a variety of peer-reviewed journals. He's the editor of The Military Psychologist and is an associate editor for the journal Military Psychology. With that, I'd like to hand things over to Joe. Dr. Joe Lyons.
Okay, thank you, Chris, for that nice introduction. And I'm excited to be here with you all today in a distributed fashion. What I'm hoping to do today is give you some background into our research on Auto GCAS and really talk about the idea of studying trust and automation from a field kind of perspective. So if we move forward, we'll talk a little bit about some of the background. We'll, of course, talk about trust and what I mean when I say the term trust and what some of the definitions are. I'll talk about this thing called Auto GCAS. What is it? And I'll talk about a couple of things. So today I'm going to be talking about some survey results that we've had with our study. We're getting ready to start, or actually already started our year 3 of the data collection for this project. So we'll talk about some of the survey results as well as some interview results that we've had from our work with Auto GCAS. And what I plan to do is talk about some lessons learned. So as we all know, automation and future for autonomy is kind of upon us, right? So how can we draw some lessons learned from existing systems and apply those toward new systems? And I'll close by talking about a couple of future directions a little bit more broadly, and I'll talk about some of the gaps. As Chris mentioned, most of this was already discussed. I've worked for the Air Force Research Laboratory since 2005, and I think the big kind of takeaway message from this chart is I've done a lot of different things with the Air Force Research Lab. I've been on the program officer side of things from a grants perspective, which was really fun. And living out in DC for a little while, I learned a lot. I was able to work with some OSD programs in terms of the Minerva program. And of course, I chartered the Trust and Influence portfolio, which is currently being led by Dr. Ben Knott at AFOSR. But back in 2013, I returned to Wright-Patterson Air Force Base, and I started this team called Human Insight and Trust. And I'll talk a little bit about that team today. The focus of the team is entirely on human-machine trust. So we have a relatively small team, but it's a relatively new team. And again, the entire focus is this idea of human-machine trust. In terms of some background within the Human Insight and Trust team, we've done a lot of different projects within the trust domain. So some of you might be familiar with the paper that Charlene Stokes and I published in 2012, looking at automated versus human aids. We're doing quite a bit of work in the area of transparency and trust. And here, we're really looking at transparency as this method for establishing shared awareness and shared intent between humans and machines. A really critical concept, and I'm going to talk about this later on today as well. So we've done some work in the area of trust and suspicion. So it turns out that suspicion is actually a different thing from trust. You know, suspicion's kind of about this suspended cognitive judgment. You're not really sure what to do. So we've done some work in terms of what that means and how to measure that. We've done some work in the areas of software code in terms of trust of software code. Dr. Gene Alicon's been leading a lot of that work for us. Dr. Slava Guznov has been leading work in the area of errors and their impact on trust in automated contexts. And we're moving forward into the areas of human-robot interaction. So we're really concerned about issues of signaling intent, how to do that in a machine fashion, looking at some of the social influences, as well as looking at this ever ubiquitous concept of human-machine teaming. So Dr. Kevin Wynn and I just are in the process of publishing a paper on human-agent teaming, and we've got some work in the area of future technologies in terms of trust of those domains. Some of our up-and-coming work looks at things like pilot trust of landing aids within the rotary wing kind of community. Here we're going to be looking at everything from symbology support to pilots to looking at some tactile support. As Dr. Brill is one of our recent hires, we're looking forward to him integrating his research on tactile interfaces in that domain as well. And the last bullet, what I'm going to really be focusing on today, is this idea of trust evaluations of fielded systems. And here we're going to be talking about this notion of auto GCAS, and we'll get to that in a second. But from more of a definition perspective, when I think about trust, I've been really heavily influenced by Roger Mayer's work in the interpersonal and management world on trust. And here he defines trust as this willingness to be vulnerable, typically without the ability or capacity to monitor what's going on. So if you're trusting of something, whether it's a person or a piece of technology, you're willing to use it when it matters the most. You're willing to put yourself at risk in relation to that system. And so what that means is this is really a human intention. This is a psychological phenomenon. Additionally, it's a relational phenomenon. So in order to be relational, there has to be some sort of reference for your trust. Otherwise, we're really talking about a dispositional trust, which is also a relevant concept. And finally, when you think about necessary conditions, it's important to think about risk. So if you're thinking about the concept of trust, there has to be something at stake. Otherwise, it really doesn't matter whether you trust something or not. It's kind of irrelevant. In terms of the trust process, you could measure a number of different things. You could measure this intention to be vulnerable, which from my perspective is probably the purest form of trust. You could measure things like trustworthiness. Here, Mayer and many others in the management literature have talked about the concepts of ability, benevolence, and integrity. These are some of the things that drive trust, right? This trustworthiness perception. As you move and shift into the human factors literature, this becomes things like machine characteristics, or as Hoff and Bashir talk about, a learned trust. These are things that will drive trust up or down, depending on the situation. So finally, we can measure things like reliance behavior. And some of the things that are important to consider here, these behaviors have to be based on choice. They have to be volitional. Otherwise, we're probably not talking about trust. We're talking about more compliance issues. And I do think it's got to be in a risky context and probably more than just simple cooperation. Okay, and finally, we talk about things like dispositional trust. We all have personality aspects that we talk about and that we bring to a situation. And of course, there's the ever ubiquitous idea of physiology. And I put a question mark here because I think that there's a great deal we can learn from physiology. And there's been quite a bit of good work in the area of trust and physiology. But I think there's a question mark because I think there's a lot more work needed in this domain. In terms of some background on the trust literature, so anybody who's ever done any kind of work in the area of trust knows that when you try to understand the trust literature, it's just impossible. The trust literature is vast, and the reason that it's vast is it covers a lot of different areas, everything ranging from management to robotics to human factors to e-commerce. I mean, there's a ton of literature out there. So what I've tried to do here today is distill a few of the references that I found personally relevant and that have kind of spoken to me from a literature standpoint. So, of course, there's the Mayer et al. 95 that I find kind of a good seminal article on the trust process. There's the Lee and C article in 2004. This really set up the idea of trust calibration and the sense that it's not just about building trust, it's about building appropriate trust. It's about building trust where trust is warranted. I think that's a really excellent concept that they introduced to the field. There's the Paraserman and Manzi paper, 2010, which does a great job looking at automation bias and complacency. These are two very relevant concepts in human factors literature, and they have a great review article talking about this. Peter Hancock and his colleagues have actually a couple meta-analyses out on the trust process. This one actually focuses on trust in robotics. And one of the things I think is kind of cool is if you look at the meta-analyses that are out and this Hoffman-Bashir article in 15, there's really this idea of a triad of trust relevant factors. So both talk about the idea of human factors, of kind of these machine characteristics or learned trust factors, and the idea that the situation matters as well. So I think that's kind of an interesting takeaway from some of the trust literature that's out there. Chen and Barnes have a nice review article in 2014 talking about human-machine teaming, which I found to be really relevant. And in fact, Jessie has been doing a great deal of work in the area of transparency as well. She's one of the pioneers in this domain. And lastly, I'll mention there was this article by Merritt and colleagues that really introduces the concept of automation schemas. This is a concept that I think is really pertinent to the human factors literature, and I'm excited to see those sorts of articles coming out. So that's kind of a snapshot of some of the literature. I know it's woefully inadequate in terms of representing the trust literature, but these are some of the articles that have personally spoken to me as we've built this human-machine trust research area. So what's all the fuss about? You know, why do we care so much about the trust process? Well, it's really complicated. So the issue is, as humans, we're not always accurate in determining whether to trust something or not. We've all heard about the situations where people have followed GPS technologies where someone has driven into a river or a lake. You know, those are kind of comical, right? We've all heard about the person that drove 700 miles when they should have driven 70 miles. You know, I think most of us would probably question in those situations, but these things happen. There's a human potential for these errors to occur. And of course, we've seen some recent incidents of cases where there's over-reliance or even under-reliance on automated systems. And what's problematic here is that when you get a very reliable and highly automated system, typically it tends to reduce workload. It tends to make things better in terms of performance in nominal conditions. However, when those conditions change or when the system makes an error, the consequences of those errors are pretty catastrophic when you have that higher level of automation that's being used in the situations. And this was one of the examples of Onash and their colleagues in 2014 that did this meta-analysis, essentially finding that the consequences for errors are really significant when the situation is where you have a highly reliable system that ultimately makes an error when it's engaging in some highly automated behavior. So what else makes this complicated? Well, the idea that trust is driven by a number of different things. You know, it's not just machine characteristics. It's not just reliability that matters. There's social factors. There's affective issues in terms of like emotions, your emotional attraction towards something. There's cognitive, of course, there's dispositional factors. So we all have biases that we bring to a situation, and these biases do have an influence. We know that the factors that predict trust change over time. This makes it even more complicated. So not only do the things that influence trust change, but their relative magnitudes change over time. So this is a highly complicated construct, and I find it an amazing thing to study because there's so many different nuances to the trust process. And finally, the last point I'll make with this chart is there's really few studies to date that I'm aware of, at least, that have looked at real technologies based on real operators with technologies that have real-world implications for performance. So I consider this the idea of R3. So this is what we're going to be focusing on today is one example of looking at real operators with a real technology that, again, has real implications for life and death in the real world. So this brings us to the idea of auto GCAS. This is the automatic ground collision avoidance system within the Air Force. We shorten it to call auto GCAS. So what is this thing, auto GCAS? It's essentially a timed collision-based automated system. Okay, so rather than saying that we're going to set a point in the world where we can't go below from an altitude standpoint, this is a timed collision algorithm that's constantly recalculating its desire to activate based on a number of things. And so let's look at some of the components here. There is, of course, a collision avoidance algorithm that determines whether a collision is imminent based on speed, vectors, and other sorts of characteristics. There's this idea of a digital terrain elevation data. Essentially what that is, there's a digital elevation map of the world that exists, right? And so this is pretty cool. We think that this is great. The problem is this is not 100% accurate. It's a really, really good map, but it's not perfect, right? So we have this digital map of the world that has some imperfections. There's this interface also with the flight control computer. So essentially, the system can override what's going on in the cockpit. It's a fully automated system that when it detects an imminent collision will take control from the pilot. And of course, there's a HUD interface, a heads-up display sort of issue. So if you look at the images on the chart here, the bottom right chart, these two, what we consider chevrons, are illuminated in red. They're not actually red in the cockpit, but it kind of shows you a transparency form for this particular tool. So the pilots will see these two carrots start to get closer. And as the carrots intersect, once they do intersect, the system will engage and do an automated maneuver. And so what that looks like is it will do a wings to level maneuver, so essentially making sure that you're not inverted or at a steep bank, and it will do a 5G pull. This is a pretty aggressive maneuver, but it's exactly what the pilots would have wanted for an evasive maneuver. They'd want something that's kind of aggressive. This is very consistent with pilot behavior, so very good on the engineers for building it this particular way. And the last point I want to make about auto GCAS is the three objectives that the engineers that built the system have kind of embodied in the system, this idea of do not interfere. They understand that pilots do not like nuisance. They don't want to be interfered with. So that's the primary emphasis of this system, is it works to the point where it does not interfere. The second tenet is do no harm. They, of course, don't want to have an activation that causes additional problems. And the last thing is avoid collision. So these are the tenets of auto GCAS that, from my perspective, make it a very well-designed system because it was done with the human pilots in mind. That idea of do not interfere was prime throughout the development of this system. Okay. And so from a trust perspective, why do we think this is a good area for studying trust? So it's, of course, an automated system that's actually fielded. If you work within the military or if you work in academia, there aren't a lot of great examples of automated systems in the world just yet. I mean, people get kind of uncomfortable with the idea of drones. Drones are not automated. They're teleoperated. So this is one area where we can actually study a fully automated system. There are, of course, real-life implications here. So this is has been described as the most sophisticated Air Force safety system ever to be fielded. So it's a pretty exciting time for the system, and it's done very well. So it was fielded back in 2014, and since that time has already accounted for 4 operational saves. You can see on the chart there's a number of other reasons we think it's important. There's potential for errors. There's potential for false alarms. There's potential for misses. So we really think it's a good ecological way to study the trust process. Not to mention that the folks that built the system had some concerns. They were concerned both that the pilots would reject the system, but they were also concerned that once the pilots got used to it, they become complacent and over-rely on it. So this idea of trust was really paramount to the engineers that built the system. And down at the bottom, I do want to acknowledge this is very much a team effort. One of my major collaborators, Dr. Newt Ho, who's at Cal State University Northridge, has been one of my main collaborators in this project. And there's been a number of people that have supported this throughout the years. This sort of a project is not doable unless you have a good team, a solid team that has subject matter experts involved, folks that can help you get into these operational contexts. So thank you to the team. I don't know if any of you are listening on the call today, but it's been a great project. Okay, so what we're doing is we started this longitudinal field study. And the idea was we wanted to baseline trust and follow it over time. As I mentioned, we're integrating into our third year of data collection. I've got some of the numbers for both our surveys and interviews down there at the bottom. I think we've done fairly well in terms of getting operational related data. I've been really pleased with the amount of interviews we've been able to accomplish, and the access, and both the access and the reception that we've gotten from the operational community has been pretty cool. And not only do we think about auto GCAS, but we also look into future automated technologies as well. You know, the Air Force is always pushing the envelope in terms of technology, so we use this as a mechanism to start to get some attitudes towards other future systems as well, which I'm not going to talk about today, but I've actually got a paper in Applied Human Factors coming up that discusses this. Okay, we're going to jump into some of the survey here. So what I've listed here, I know this is kind of an eye chart, but we've got the actual survey scales that we've created for this study. You'll notice a couple things. You'll notice that many of these are very short scales. If you ever want to do a survey in the operational community, you'd better make it short. Otherwise, people just aren't going to do it. But we have the representative items shown here, as well as the reliability coefficients for these. So some of these had some borderline reliabilities, but given the small scales that we had, we think we did okay in this particular study. So again, we looked at things like trust. Of course, we looked at a lot of the predictors of trust. Things like performance always comes up in the trust and automation literature. Transparency, of course. The idea of benevolence, almost like an institutional benevolence. Whether people think that there's benefits to them having the system on, and also whether they think it benefits other people. So there's some kind of the social aspects here with the benefits. We gauge things like their confidence, whether they think auto GCAS has made them more confident in flying. And we have this thing called aggressive flying down here. So the developers were really concerned that people would become more aggressive because they have this tool, this automated tool that can protect them. So we wanted to gauge that, and we gauged this through interviews as well, but we wanted to have a survey scale to capture that. And we used Stephanie Merritt's automation schema, specifically the high expectations subfacet of automation schema. And so what did we find? We have the means listed here. You can see almost all of the variables that we would expect to be high were very high, and this was results from year one. Things like trust was fairly high. Perceived performance was fairly high. And so I want to make a comment that this was after about 6 months of fielding with the system. So this wasn't just out of the, the gate here, but it was about 6 months after the fleet got the system. So they've been flying with it for a little bit at this point. It had some growing pains, but for the most part, it's been a very effective and reliable system. But you can see here with our subjective scales, most of these were fairly high. The ones that are low, the aggressive scale and the schema scale, so let's talk about that for a second. Most of the pilots self-reported very low probability of using the system to fly more aggressively, which is exactly what we would want, right? We don't want them flying more aggressively because they have the system. That kind of goes counter to the intent of the system. And their automation schema in terms of high expectation was fairly low. So I guess as a community, these fighter pilots were fairly low in their expectations of technology, which is kind of humorous. But it is what it is. So these are the means. Now, if we go to the next chart, we can look at some of the correlations. And here we're looking at correlations among the set of predictors that we think should be related to trust. So here we see significant relationships with all the factors that we think would be related to trust. So automation schema, the performance perceptions, transparency, benevolence, benefits, etc. And we looked at a couple outcomes. So we looked at how did trust link to their confidence. And we see a reliable link there, as we would expect. Higher trust leads to higher confidence in this environment. And interestingly, we see a non-significant relationship with aggressive flying. This is really important for a number of reasons. So it's important because we can show the folks that designed the system that just because someone's higher trusting of the system, they're not going to be more aggressive in their flying, not due to the trust aspects here. And secondly, it's kind of interesting to see that it's a non-significant relationship, so we don't get as much common method variance. It was one of the concerns as well. So at least we got a couple, and there were a few others that didn't have significant relationships, but I was happy to see that non-significant relationship with aggressive flying. So these are the bivariate correlations. What we did next, and this is a part of a paper published in Military Psychology, we looked at the unique predictors of trust. So based on the correlations, what again has that unique relationship with trust as the outcome? And so what we found was that the automation schema had a marginal relationship with trust. Performance expectations and beliefs had a reliable link, as did perceived benefits. So what I find interesting here is that if you go back to that Hoffman-Bashir article, there's not just one thing that predicts trust, right? There's a number of things that predict trust. Here, we're tapping into some individual difference variables here. We're tapping into, of course, performance perceptions in terms of whether they think the system's going to perform reliably and whatnot. And we're looking at things like benefits. So these are all things that are really relevant to the trust process. And this was about at the 6-month mark for our pilots here. So this was year 1. And again, I was pretty encouraged by the idea that we found multiple things predicting trust early on. So this is when you're going to get the most kind of uncertainty associated with trust. So we might have greater affordance for things like individual differences and other factors. The next chart starts to look at the year 2 means for the survey. We had the same scales that we used, so we had the consistency there. I know a lot of you are probably thinking, what's the repeated measures implications here? Just to kind of couch that up front, the problem we had is very few pilots came back and took the survey in year 2. So we had very high attrition rates between our pilots in year 1 to year 2, which I think anybody who's done work in this area can resonate with. It's really hard to get operational folks to do the same thing twice, right? So, however, we did look at one particular factor. We looked at trust, and we found that if you only isolated those who took the survey in year 1 and year 2, and you measured their trust, there's actually a reliable increase in those individuals. So going from a year 1 to year 2 standpoint, we actually found a reliable increase in trust. But that's not reflected very well in these means, because these means capture everyone involved, not just those folks that took the year 1 and year 2 surveys. But ultimately, what we find here in year 2 is we see a lot of the variables very high. So looking at transparency, benevolence, and benefits, these are all above 6 on a 1 to 7 scale. This is really high. So the pilots really have positive views of the system. And at this point in year 2, there had already been some operational saves. So the stories that are getting out about the system are very positive. And so we're kind of seeing that reflected in the data. We see again the kind of low aggressive flying variable and the relatively low automation schema as well. We again looked at the correlations with the year 2 data set, and we find mostly consistent results with year 1. All of our set of predictors were reliable with the exception of transparency, which no longer had a reliable link to trust. We can talk about why that's the case here in a second. We also find that again, these reliable link with confidence. Higher trust leads to higher confidence, which is good. And again, we see this non-significant link with aggressive flying, which is really cool. So we're not seeing, at least from the self-report standpoint, this notion that higher trust leads to greater complacency in relation to the system, not at a wholesale perspective. Okay, so those are the correlations for year 2. We move on to look at the regression, right? So again, we're looking at the unique predictors here. And what we find in the year 2 data, the value for automation schema is relatively the same. It's actually slightly higher, but it's no longer reliable, I think, because we dropped some sample size here. We went from 140 to 100, which is still pretty good, but I think that was enough to kind of kick that as to not being marginally significant anymore. And we see this really strong effect of performance. So what we're seeing here is that as the system has gotten more use, people have gotten more exposure to the system, this notion of performance perceptions is really the key variable that's emerging. And this is very consistent with the trust literature. So it's kind of jiving very well with a lot of the laboratory-based research in this domain. Okay. Also, I think that if you reflect back on the means, the means for transparency, benevolence, and benefits are all very high. So I think what we're looking at is some range restriction here, possibly some ceiling effects for those different variables. Okay. And so where do we go from here? One of the interesting things that I get asked of a lot as a government researcher studying this sort of research, hey, Joe, tell me about some generational effects. Tell me about the millennials. Should we be worried about the millennials? Should we be worried about younger generations? And so I actually wanted to test that in this sample using some of the data that we have. So here's what we did. We looked at this idea of experience. And this experience was rated as the number of flight hours in the F-16. Okay, we operationalize this experience as you were experienced if you had more than 500 flight hours, and you were a novice pilot if you had fewer than 500 flight hours. And this is kind of based on Air Force standards here. And we wanted to look at this notion of potential for complacency. So we had this aggressive flying variable that we could use as kind of a rubric for complacency potential. And what we did was we looked at essentially the experienced versus the non-experienced pilots. And we wanted to see were there differences based on trust and were there differences based on complacency potential. So in the human factors literature, you can see quite a bit of research on generational differences in automation use. For example, Rich Pack down at Clemson University has done a great deal of work in this area, and it has some very interesting findings. But the problem is, from a military perspective, most of the samples that are used are really older samples, people that are above the age of 60. That's really not relevant for a military population, right? So, and most of that research that's been done is focused on the idea of cognitive decay. So the older you get, the less, cognitive function you retain. And that's not me saying that, that's what the literature says. So if there are folks out there in that category, don't hold me to the fire against that. But this is kind of what some of the literature would suggest. And so I see this really, there's a need for more military relevant ages in this kind of a question to get at this, hey, are there generational effects or not? So if we go to the next chart, we see on the left-hand side, we looked at, again, both trust and complacency potential as indexed by that aggressive flying variable. So what we see is there are no differences in trust. If we just ask simply about trust, we don't see any differences between the experienced versus the novice pilots. This is a good thing, right? So they're kind of at the same level of trust. However, if we look at this notion of complacency potential, we do see reliable differences where the novice pilots, the least experienced pilots, are saying, yeah, I'm more likely to use this tool to fly more aggressively, to use it against what it was kind of designed for. And so we see that reliable effect. This is interesting, and what I think is going on here is this is driven by system knowledge, essentially. So your novice pilots are going to have less experience dealing with this system as well as less experience dealing with the F-16. So I think there's a system knowledge gap here is what we're capturing. That's something that I'm kind of speculating about. I think there's the need for a great deal more research in this domain to kind of pull out what we think is driving some generational effects. I hear this all the time about generational effects, but I've not seen a lot of data that actually demonstrates generational effects. I will say one thing about the automotive industry. So I've seen some recent research suggesting that the millennial generational group essentially has the most positive views towards automated technologies in cars, right? So they're most positive about, hey, this car can do some automated features. And I think that's pretty logical if we think about the younger generations. However, here's the problem. This paper also talked about the fact that the millennial generations are also the least likely to own one of these cars, right? So if we couple the idea of high kind of expectations, high performance expectations with lack of experience, yeah, that can be a recipe for disaster in terms of complacency. So I do think that there's a need for this kind of research, and I'm excited to kind of start dabbling in this a little bit. Okay, so that's one of the things we looked at. Let's think about the interviews here for a second. So we went out and we did a bunch of interviews with these operational pilots. We asked them essentially, hey, what are the things that drive your trust of auto GCAS? And I think a lot of these resonate with what the literature would suggest as predictors here. So naturally, system performance is one of the key aspects. So auto GCAS has had to date 4 operational saves in a very small amount of time of being fielded. This is phenomenal. There are 4 pilots and 4 aircraft that are around today because of this system. It's a great news story. In fact, what you can do is, if you have access to an internet terminal right now, Google auto GCAS saves pilot. There's a nice declassified video that's out there from the most recent save, occurred back in May of 2016, where a pilot was G-locked. He essentially experienced gravity-induced loss of consciousness. He passed out in a very high aggressive maneuver and was essentially pointed straight at the ground, going very fast, and the system saved his life. So that's a great video to watch, kind of give you some of the background with auto GCAS. And in terms of system performance, the pilots really resonate with the idea of nuisance-free operations. So they don't view it as an interference. This is critical for their trust. If they viewed it as an interference, pilots would shut it off, and they do have the capability to shut it off if they want to. Another thing that was really relevant for trust was they got to go out and try it. So there's this great system called the Pilot Activated Recovery System, which is essentially an easy button for auto GCAS. It's a button you can press to do a manual auto GCAS maneuver. So it's a great way to kind of get familiar with how it operates and the aggressiveness of that maneuver. Other things that are really relevant, the idea of the business case. These pilots have experienced decades of pilot loss because of CFIT, this controlled flight into terrain. Believe it or not, this is still a big problem for the Air Force. It's where we lose a lot of folks during training and otherwise. So the need for the system was kind of already primed to be high. This was a critical factor for trust of auto GCAS. And this notion of perceived benevolence, almost like an institutional benevolence, is incredibly high. You know, these people view this system as definitely there to help them. It's not there to replace them. It's there as support to the pilots. Other things that were relevant, of course, error attribution. There were some growing pains with the system. So the pilots had the ability to attribute those early errors to some hardware issues because there were some hardware concerns and issues when it first fielded. Those have since been remedied, of course, but they attributed those to the hardware versus the software, which was really key to preserving their trust. Other factors, the idea of transparency. The pilots really loved the idea of those chevrons, the HUD indicators that show, hey, the system's working. I might need to consider what's going on, what I'm doing, you know, flying at that particular time. Okay, so you can kind of read the rest of those as well. So we found a number of really good predictors of trust based on the interviews, and my colleague, Dr. Ho, is in the process of publishing one of those papers as well. Okay, so what are some lessons learned for new technologies? So really thinking about the ideas of transparency, I think is critical. So both from a display standpoint, you know, you need to give people some cues to show you the system's actually working and it's working as intended, but also transparency from this idea of intent. You know, auto GCAS worked really well because pilots thought it was there to help them. They thought it was there to not get in their way, right? This idea of nuisance-free operations was really important for their trust. So this kind of goes back to the idea of human-centered design, how we can try to consider what the human needs and values and integrate that into the design. So when you're thinking about pre-implementation, you need to really think about also the business case, because people are going to ask, why do I need to, what's wrong with the status quo? Why do I need to do something different? That's going to be an important factor driving trust. And of course, trying to understand potential barriers. These are hard to understand if you don't get out there and try to learn what the areas of resistance are. These could be anything from a cultural factor to, you know, organizational processes. You know, it's really about understanding the narrative surrounding that technology. Okay. In terms of post-deployment, you've really got to take ownership of the narrative. So one of the things, and I think it's pretty logical, that we learned through this process, the pilots all talk. They all talk about the technology. Some of them love it. Some of them didn't love it at first. And that got around as well. So you really need to try to understand the narrative and own it. Try to take control of what's being said about the system. In this case, we shared success stories. So in particular, the videos of auto GCAS working as it saved somebody, that was the biggest trust booster for this particular population. You know, the GLOC save that's now out there for the free world to see is now the poster child for this technology. There were, of course, other videos that aren't declassified out there that were able to be shown to the pilots that were really good in terms of generating trust of the system. But not only sharing the success, but also sharing the failures. They want to understand what's going on with the technology. Is it working? If it's not working, why? So that was really important as well. It's important to think about metrics to evaluate success. This is something that I give credit to the Air Force for allowing us to do this study, to kind of get out there and gauge how things are going, because it's hard to understand when you insert a piece of technology how it's going to be used. There's always going to be some unintended consequences, and we have seen some of that with this technology that I don't go into because they're not really open source sorts of things, but there are some things that change that you don't anticipate. So you need to get out there and try to capture that as best you can. You need to think about anchoring behaviors in the culture. So one of the really important things that they've done with auto GCAS is if a pilot experiences an activation, they don't hold that over their head. They don't come back and say, well, you must have been doing something wrong. Why did you do that? No. Instead, they come in and they talk about it as a group to say, what was going on in this situation? How can we learn from this to improve on the next situation? Because one of the most amazing things I found in this project was how much there's this wingman culture among the pilots. You know, there's of course the typical razzing that you would expect among fighter pilots. That of course happens. But there's this really strong wingman culture. They really value learning. They value their safety. And if someone gets into trouble in operations and they experience an activation that saves them, they want to learn about that. They want to be able to share that. So it's been a really positive experience in that sense. Okay. So next, in thinking about research in this domain, so thinking about field research on trust, one of the big eye-opening factors for me has been how difficult it is to do longitudinal research with operators. I had this false assumption in my head that, oh, we're going to get hundreds of people every year. We're going to be able to do longitudinal analyses with the pilots. It just hasn't worked out that way. It's just challenging. It's something for us to think about as we do field research and trust in automation. It's just hard. So thinking about access, I wasn't even sure when we started this project if we were going to get 20, 30 interviews. We ended up with hundreds. We had hundreds because we had a subject matter expert on the inside helping us. They got us smart on Auto GCAS. We spoke the same language, and we were able to use that to get buy-in. If we would have shown up on their doorstep, in our shirt and ties, hey, we're here with AFRL, we'd like to do some interviews with you. Yeah, wouldn't have worked out very well. But using the subject matter experts to get that critical buy-in was essential. Other things, we think it's really interesting to see that a lot of the things that we see in the laboratory for trust automation are really kind of showing their appeal in the field. They seem to be very, very relevant, and we view the models as being pretty robust. So the idea of performance and error types, this idea of false alarms or the nuisance for the pilots was a critical factor. Ideas of transparency are really important. Individual differences, there's this idea of automation schema. This actually has been shown to link to pilot trust. Pretty cool. And of course, the notion of benevolence. If you look in the management literature, benevolence is one of the key aspects of trustworthiness. I think this has a huge role for technology as well. Okay. And so thinking about looking at the future, and I know I'm kind of running out of time here, I definitely would advocate for more applied work in the trust area. It's been really eye-opening and a nice convergence, I think, on some of the literature, but it's been a really fun project. More broadly speaking about some of the gaps, I see a lot of people talking about physiological metrics. And I think physiological metrics are great. What I think is missing is the rationale for using them in particular contexts. So instead of applying a kitchen sink approach to say, we're going to measure all these things and see what's related, what should be related to trust? If we're thinking about this as a research community, let's try to be more theoretical about how we approach this trust problem from a physiological perspective. So that's one of the things I think could be useful. I do think there needs to be more research on intent-based transparency. And real quickly, I'm going to try to talk to what we mean by that. But this notion of signaling positive intent, how does that occur with a machine? If we're working with a robotic system or a form of automation, how can that thing signal a positive intent? This is, I think, a wide open research area that I'm excited to dive into. And of course, understanding methods for establishing shared awareness and shared intent. The whole idea of shared awareness, Jesse Chen has a really good transparency model. So the situation awareness-based transparency model based on some of Micah Ensley's work. And it's this whole notion of shared awareness is really important. I truly believe as we get systems that get more and more decision autonomy and decision initiative, so both kind of the authorization to operate and the capabilities to operate, these notions of transparency are going to be really important. So let's real quickly kind of run through what I mean by transparency. So when I think about transparency as a broad method for establishing shared awareness and shared intent, I kind of view it as incorporating a lot of different factors. So everything from the intent or the overall purpose of the system to environmental models. How is it sensing the environment? How reliable is it in sensing the environment? To the task and analytics. What's the task that it's doing and how reliable is it in doing that? And the analytical piece is kind of understanding the black box. So if we give operators a black box, they're simply not going to trust it. They've got to understand what's underlying that black box. What are the assumptions of the algorithms it's using in incorporating its real-world activations? We can think about things like teamwork and human state modeling. So what's the division of labor between the human and the machine? What's the human state? There's a great deal of, we talked about physiology a little bit, there's a great deal of value in our physiology. It tells you a lot about us as people in terms of our awareness, our workload, our stress levels, our levels of engagement. How can we leverage that and apply it in this human-machine context? And on the teamwork side of things, I just want to mention, so Ken Ford was up here in Dayton for the International Aviation Psychology Symposium this past week. One of the really cool things that he said during his keynote talk was that AI research has been pushing it in some of the wrong directions. What basically one of the things that I took away from that was, instead of thinking about AI as working towards independence, AI researchers should be working toward interdependence between the humans and the machines. I thought that was a really cool way to think about human-machine teaming, and this notion that it's not about taking the humans out of the loop. It's about building systems that maintain us in the loop so that we don't experience catastrophic errors when things go south. And guess what? Any system that we build is going to make an error at some point. It's just inevitable. We've seen this in autonomous cars. We see this in commercial aviation. There are going to be errors. The key to preserving performance is going to be maintaining that human in the loop perspective so that we can recover from those errors. And the final point that I'll make in this transparency model that I've been trying to push a little bit is the notion of social intent. You know, if we think about factors that make us trust other people, the social intent aspect, you know, what is their intent in relation to us is really important. I truly believe that as systems, whether they're robotic systems or agent-based systems or simply software on our computers, as we give these things greater capabilities and as we give them greater envelopes to operate, the notion of social intent is going to be really important. I'm going to want to understand that system's goal in relation to my goals, right? That's kind of a social factor, and that's going to be really important in terms of driving our trust of future systems. And I guess what I'll close with on this last chart is, forgive the cartoonish nature of this, this is what we want to avoid. We want to avoid a situation where, whether it's a car, a plane, a missile system, or a robotic system that's out doing some work for us, we want to avoid the situation where it tries to pull us in after we're already in trouble, right? That's the whole notion of transparency. We want to get ahead of that curve to stay engaged with the system and know what's going on so that we can do the right behaviors, whether that behavior is trusting it and relying on it, or whether that behavior is saying, you know what, I think the system's compromised. I need to take manual control at this point. So I will close with that and have a couple pictures here at the end of F-16s that have auto GCAS capable systems on them. It's amazing how low to the ground they fly sometimes with their operations. We think about aircraft as being super high. A lot of these folks fly really low for obvious reasons for the military. But it's been a pretty exciting project, and I thank you for your attention. All right.
An answer. So if you have any, can you all hear me now? Okay, great. At this point, we're going to begin the question and answer portion. If you have any questions, feel free to type them in either the Q&A window or the chat window. And while you start preparing your questions, I'm going to start it off. Joe, what do you think the biggest barrier to trust you observed in the auto GCAS studies was? What was, clearly nothing was unsurmountable, and it sounds like the system has been fairly widely accepted, but you know, what was kind of one of those lingering barriers that you saw?
Yeah, thanks for that question, Chris. I think the biggest barrier that we saw to auto GCAS, and this was going back in time before it was actually fielded, was really the notion from the pilots that this thing's going to interfere with me. It's going to create some nuisance. It's going to create false alarms that are going to interfere with my ability to fly. So the biggest barrier was really convincing pilots through both education about the system, the actual design, the engineering of the system that was designed to essentially negate nuisance, and showing them through experience with the system that, yeah, this system is not going to interfere with you during your operations. I think that was the biggest trust barrier, that once pilots kind of understood that, their acceptance started to skyrocket.
Great. Can you talk just a little bit about the iterative design process used for auto GCAS? One of the things you mentioned is you fed some results back into the pilot community or the developers of the system.
Yeah, so in terms of the iterative design process, so auto GCAS was actually a technology that was in development for decades. So pre-implementation, one of the cool things I think they did was they leveraged this human-centered design approach. They really tried to understand pilot anxiety in terms of how close they'd be willing to fly to a piece of terrain without maneuvering. So in my eyes, this was the pinnacle example of human-centered design. Over a beer sometime we could talk about what that really meant in this case, but a lot of design went into it and a lot of consideration for human elements. So post-implementation, yeah, we went out there and we got some results, and because we work at AFRL and the people that built Auto GCAS were both from NASA as well as AFRL, we're able to partner with those folks and feed that information back into the system to continually modify it. So there was actually one instance of a nuisance activation that was somewhat systemic that we were able to identify because, during the testing process, you can only test so much, right, based on resources and whatnot. So we were able to find this systemic problem with the system, feed that back into the operational community that designed it, and they were able to fix it. So that will be fielded in a subsequent iteration of Auto GCAS.
Great. I have a question here from Larry Shattuck, and he is wondering, did you look at how often pilots turn off the system?
Yeah, a great question, Larry. We do not track that. I'm trying to think of why we don't track it. It would be, we ask them what would drive them to shut it off, but we don't track the individual instances because the data would be kind of insurmountable. It'd be basically, in order to capture behavior like that in the cockpit, we'd have to go through some declassification issues, which make answering that kind of question really difficult for researchers. The operational community could probably do it if they were tracking it, but we haven't looked at that from the research standpoint. But we do try to capture, however, from the interviews, what would make you shut this off? What would be so bad that you would turn the system off? And that's reflected in some of those trust antecedents that we talked about.
Great. So you mentioned autonomous cars, and there's a lot of buzz about autonomous systems, or sometimes people speak in terms of increasingly autonomous systems because we don't necessarily have truly autonomous systems here yet. But do you have the general sense of if the trust factors for automated versus autonomous systems might be fundamentally different?
Yeah, that's a really great question. So kind of the whole controversial dichotomy between automation and autonomy, this whole idea of an autonomous system. So for me, automation, and I got to start with some definitions here. So for me, automation is a system that reacts to set discrete criteria. It's going to react the same way in every case, right? Based on how it's programmed, right? It's going to react in ways that are very predictable. At least if it's designed well, that's how it's going to work. As we move towards autonomous systems, and again, I think there are very few actual examples of this in the real world today, but we're moving in that direction for sure. I think from a definition standpoint, autonomous systems get to this idea of unpredictability. There's going to be some level of awareness of how they might react, but you're not really sure until they experience it, especially if you think about learning systems. So learning systems that can change the way they interact with their environment based on prior experiences. That's the whole notion of being human, right? So we're somewhat unpredictable. But here's the thing. I think what we need is a different level of transparency and a different level of training, if you will, with these sorts of systems. So as you're starting to move towards learning systems, the kinds of affordances you provide during the learning process are critical. And it's critical to understand that during that process. So if you think about a robotic system that, let's say AI is successful, and you build some system, it's not going to work perfectly out of the box. It's not going to work exactly how you expect out of the box. There's going to have to be training with that system. So if you understand the affordances within which it's been trained, you start to understand some level of predictability and how it's going to react to novel situations. So I guess that's kind of a long-winded way of answering your questions. I do think that they're different. The things that will drive trust are a little bit different, but I think as you move towards autonomous systems, I think this notion of intent is going to be increasingly important, because if there's uncertainty with how it's going to react, you want to know the foundation, the architecture for how it's going to react in relation to you. I think that's going to be really important. At least that's what I hope, because it's the areas that we're diving into in our research.
All right. And with that, I think we are out of time. So thank you very much, Dr. Joe Lyons. If you have any further questions for Joe that you think of after this webinar or would like to ask him offline, his contact information is shown on the slide, and these slides will be available online in PDF format. Also, as a member of HFES, you can access any of the archived webinars at any point by going to hfes.org. This webinar will be available in just a few days in the archive. Just as a reminder, if you have any suggestions for webinar topics you might be interested in or particularly good speakers you'd like to recommend, then feel free to contact me. And again, my name is Dr. Chris Brill. My contact information is on one of the first slides. So with that, I'd like to conclude this webinar. Thank you very much for your attendance.